Colonizing Mars, the next frontier for humanity. Colonizing Mars represents one of the most ambitious and exciting endeavors in human history, capturing the imagination of scientists, space agencies, and the public alike. With rapid advancements in space technology and a growing interest in space exploration, humanity is now closer than ever to making the Red Planet a second home. This monumental task involves overcoming numerous scientific, technological, and ethical challenges, but the potential rewards are vast, ranging from safeguarding the human species to gaining unprecedented knowledge about our universe. Why Mars? Mars, the fourth planet from the Sun, is considered the most viable option for human colonization due to several factors. Unlike other planets in our solar system, Mars has a relatively mild climate by planetary standards, with temperatures that occasionally reach levels similar to Earth's coldest regions. It has a day length similar to Earth's, 24.6 hours, polar ice caps that contain water, and seasonal changes. Additionally, Mars possesses essential elements like carbon, hydrogen, nitrogen, and oxygen, which could potentially be extracted for life support and fuel production. The journey to Mars, challenges and preparations. Reaching Mars is not an easy feat. The journey to the Red Planet takes about 6 to 9 months, depending on the alignment of Earth and Mars. During this time, astronauts would face prolonged exposure to microgravity, which can lead to muscle atrophy, bone loss, and other health issues. Moreover, they would be exposed to cosmic radiation, which poses significant risks of cancer and other health complications. Solutions such as advanced shielding, artificial gravity systems, and better spacecraft designs are being developed to mitigate these risks. Establishing a Mars base, building the first human settlement. Once on Mars, establishing a base is the next critical step. The initial habitats will likely be constructed using inflatable modules or prefabricated structures brought from Earth. These habitats must be designed to withstand extreme temperatures, radiation, dust storms, and other environmental hazards. The idea of using in situ resources, like regolith, Martian soil, to create building materials using 3D printing technology is gaining traction. This method could drastically reduce the cost and resources needed to transport materials from Earth. Water will be essential for the survival of any human settlement. Fortunately, recent discoveries have confirmed the presence of water ice on Mars. Future colonists could extract this water by mining ice deposits or filtering and purifying underground water sources. The extracted water can be used for drinking, growing crops, and generating oxygen through electrolysis, creating a sustainable ecosystem, growing food and generating power. A sustainable colony on Mars will require reliable food and energy sources. Scientists are exploring various agricultural techniques to grow crops in Martian soil. This would involve using hydroponics or aeroponics systems to cultivate plants indoors, where conditions like temperature, light, and humidity can be controlled. Experiments conducted on the International Space Station, ISS, have already shown that some crops can be grown in microgravity environments, providing a foundation for future research. For energy, solar power is considered the most viable option due to the availability of sunlight on Mars. Solar panels could provide electricity for habitat systems, life support, and research facilities. Nuclear power is also being considered as a backup energy source, especially during dust storms that can block sunlight for extended periods. Adapting to the Martian environment, life and survival. Mars has a thin atmosphere composed mostly of carbon dioxide, with surface pressures less than 1% of Earth's. This atmosphere provides little protection from solar radiation, making it essential to develop habitats that shield against radiation and maintain a stable internal environment. The low gravity on Mars, about 38% of Earth's gravity, also poses unknown challenges to human health over extended periods, potentially affecting muscles, bones, and cardiovascular systems. Developing advanced life support systems will be crucial for recycling air, water, and waste. NASA and other space agencies are already working on closed-loop life support systems that can recycle almost all water and oxygen, reducing the need for resupply missions from Earth. Ethical and political considerations. Who owns Mars? Colonizing Mars also brings forward a host of ethical, legal, and political questions. Who will govern Mars, and under what laws? The 1967 Outer Space Treaty, signed by over 100 countries, prohibits any nation from claiming sovereignty over celestial bodies, which means Mars could be considered a global commons. The governance structure for a Mars colony would need to be carefully considered to ensure fair use, peaceful exploration, and respect for international agreements. The benefits of Mars colonization. a new era for humanity. The potential benefits of colonizing Mars are vast. It could serve as a backup location for humanity in the event of a catastrophic event on Earth, such as an asteroid impact or nuclear war. Mars colonization could also drive technological advancements, foster international cooperation, and inspire future generations to reach for the stars. Moreover, it could help answer fundamental questions about life beyond Earth. By studying Mars up close, scientists may find signs of past or present life, deepening our understanding of life's origins and prevalence in the universe. Conclusion: the path forward. While the dream of colonizing Mars is closer than ever, numerous technical, scientific, and ethical hurdles remain. However, with growing interest from private companies like SpaceX and Blue Origin, as well as governmental space agencies like NASA and ESA, the vision of becoming a multi-planetary species is becoming more tangible. The next decade could see the first human footsteps on Mars, setting the stage for a new chapter in human history, one where Mars is not just a distant red dot in the sky, but a second home for humankind.